You are sitting at your desk, staring at a glowing search bar, typing out the exact same query for the third time this week. Maybe it's a specific coding syntax, a basic formula, or formatting a spreadsheet cell. When this happens, it is easy to assume the worst. You worry your attention span is fractured. You might even wonder if your ability to retain basic information is slowly fading away. But you aren't losing your mind. Your brain is not glitching at all, and your intelligence is completely intact. In reality, your mind is operating with ruthless efficiency. It is actively wiping those everyday facts from your memory, and it is doing so on purpose. This targeted deletion is an ancient survival mechanism, one that has rapidly adapted to our digital environment. The question is why your brain chooses to throw this specific information away. Historically, human survival did not require a single person to memorize everything. Instead, we distributed knowledge across the group, using this to remember which friend knew how to fix a car. This diagram illustrates transactive memory. The central self node doesn't store data locally. Instead, a pathway illuminates, pointing to the neighbor holding that skill. But search engines bypassed this network. Those human connections dissolve, rerouting all pathways to a single, centralized database. Cognitive researchers call this the Google effect. When your brain recognizes a massive library of answers is accessible right in your pocket, we traded our historical network of human expertise for total reliance on a single, completely frictionless digital tool. Look at this cross-section of the human brain. Every time you encounter a new piece of digital information, this biological machine runs an immediate audit. It makes a strict biological calculation. Before committing a fact to memory, it weighs the biological cost against the expected benefit. Physically constructing the dense neural connections required to hold a fact in your long-term memory demands an immense amount of biological energy. Conversely, just storing the location of where to find the data requires almost zero effort. This biological flowchart compares the options. Storing a fact is a complex, tangled process. Storing its location is a simple, straight line. Your brain actively chooses the path of least resistance. The heavy-duty memory pathway is abandoned, and energy resources cascade down the low-effort route. Without the mental effort required to hunt down an answer, the specific neural sequences needed to permanently lock data into your brain are never triggered. By treating our devices like external hard drives, we continually instruct our minds to skip the memory creation process entirely. This system works perfectly until you step away from your screen. You enter a meeting or try to solve a problem on the fly, and your device isn't immediately available. This is the onset of search amnesia. It is the direct result of your brain's hyper-efficient energy rationing. When you outsource your cognitive load, your capacity to spontaneously recall facts during a live conversation collapses. Outsourcing your knowledge to an external search engine leaves you with a completely blank internal drive right when you actually need it. The next time you reach for your keyboard to look up an answer, pause for a moment at that exact threshold. You cannot override your biology, but you can change the environmental variables your brain relies on to make its energy calculation. To synthesize a memory, you have to reintroduce intentional friction into your learning process. That mental struggle is the biological prerequisite for retention. Before you open a new tab, force yourself to wait 10 seconds. Use that time to actively try and recall the answer from your own mind. Deliberately blocking the path of least resistance signals to your brain that it needs to invest the energy. You stop passively searching, and you start rebuilding your cognitive independence.